Colloid can be prepared by a variation of techniques involving physical, chemical, as well as some dispersion method. These techniques are based on a variety of principles. There are two principal ways of preparation of colloid. One, dispersion of large particle or droplets to the colloidal dimension. Second, condensation of small dissolved molecule into large colloidal particles by precipitation, condensation, or redox reaction. In the dispersion methods, larger particles of a substance or suspension are broken into smaller particles. In mechanical dispersion, the substance to be dispersed is suspended in the dispersion medium and then ground to final state by mechanical means. Whipping of curd into lassi, beating the white of an white egg, and colloidal solution of black ink, paints, varnish, dyes are obtained by this method. Peptization is the process of forming stable colloids by using an electrolyte to break up a precipitate and disperse it into the colloid. In order to perform peptization, we need an electrolyte, which is called a peptizing agent. The precipitate particles adsorb onto the ions of the peptizing agent, and then electrostatic repulsion, or we know that repulsion between two compounds with like charges cause the precipitate particles combined with the electrolyte ions to mix with the colloidal solution. So a stable colloid will be formed. Bradick arc method. This method is used to prepare salts of metal such as platinum, silver, copper, or gold. The metal whose salt is to be prepared is made as a two electrode immersed in dispersion medium such as water. The dispersion medium is kept cool by surrounding it with a freezing mixture, or we use it ice bath. An electric arc is struck between the electrodes. The tremendous heat generated by the arc vaporizes the metal, which are condensed immediately in the liquid to give colloidal solution. The colloidal solution prepared is stabilized by adding a small amount of potassium hydroxide to it. Solvent exchange is a condensation method. In solvent exchange, if a true solution of substance K in solvent X is added to another liquid Y, which is miscible with solvent X but slightly soluble or insoluble with substance K, the substance K separates out to form particles of colloidal size. This is due to decrease in solubility of K in the presence of liquid Y. One example of solvent exchange: a solution of sulfur in alcohol is poured into water. A colloidal solution of sulfur is obtained due to lower solubility in water. This is similar goes to phosphorus. The reason why sulfur and phosphorus are soluble in alcohol but insoluble in water. So that prepare first the alcoholic solution and pouring them into excess water. Using chemical techniques, we can prepare lyophilic or lyophobic salt. The chemical techniques we have here is condensation method, which is double decomposition. In double decomposition, we have hydrogen sulfide is passed through a solution of arsenious oxide in distilled water and we can get a colloidal solution of arsenious sulfide. Colloidal solution can be formed when a substance is react with water, and uh, we can say this is a hydrolysis process. For example, the use of boiling water to obtain a reduced solution of ferric chloride. Another technique of preparing colloidal solution of metal such as silver, gold, as well as platinum involve the use of reducing agent for reduction of salt solution of this metal. So example of reducing agent, we have stannous chloride. In oxidation process, a colloidal solution of sulfur is made to pass through an aqueous solution of sulfur dioxide. It can also be obtained by passing the gas through a solution of an oxidizing agent. So the oxidizing agent can be either bromine water or nitric acid. Purification of colloid is required to avoid precipitation and or coagulation. And there are few ways to purify the colloid. One is dialysis, electrodialysis, ultrafiltration, ultracentrifugation. And we are going to focus only on dialysis. In dialysis, there are a form of filtration in which the pore size of the parchment cellophane membrane is small enough for the colloidal particles to be held back while ion and small molecule of a true solution pass through. We have here colloidal solution, and inside there will be colloidal particles, and there will be impurities or electrolyte or a small molecule inside this colloidal solution. What happened is only the ions or small molecule can diffuse through the parchment membrane. Okay, so the colloidal particle will remain inside this membrane or tube, and this is how we can purify the colloid using dialysis process.